Welcome back to Anton Math, and in this video we're going to be introducing some new trig identities, and we call these the formulas for lowering powers. Now if we have a square of sine, cosine, or tangent and we need to lower it down so that there's no powers, so that everything's just at power 1, we can use these formulas to do so. Now these first two formulas for sine squared and cosine squared become very, very useful when you get to calculus 2. It's very difficult to take the integral of sine squared of x all by itself, but cosine of 2x is actually a very easy integral. So writing sine squared of x in this way allows you to evaluate these integrals that you wouldn't be able to evaluate if you just tried working with sine x alone. All right, so let's take a look at these. Now where did these ones come from? As we've been going along, we've been deriving all of these, so let's figure out where these come from. And we notice the common entity here is cosine of 2x. So let's take a look at our double angle formula for cosine. Cosine of 2x equals 1 minus 2 sine squared x. Now remember, this is one of the three different formulas that we had for cosine of 2x. So now I have a sine squared here, I have a cosine 2x, so let's try to isolate this sine squared. I'm going to subtract this 1 from both sides, and I'll go ahead and flip these sides. So I'll have negative 2 sine squared x is equal to cosine of 2x minus 1. Now I'm going to divide by negative 2, and I'm going to get sine squared of x is equal to, dividing by this negative is the same as multiplying by negative 1, so it's going to become a positive 1 and a negative cosine. So it's going to be 1 minus cosine 2x all over 2. And this is exactly our formula for reducing sine. Now if we look at the other double angle formula for cosine, cosine of 2x is equal to 2 cosine squared x minus 1. We can do the same thing. I'm going to isolate this cosine. So I add 1 to both sides. I get 2 cosine squared x is equal to 1 plus cosine 2x. And dividing by 2 gives me that cosine squared x is equal to 1 plus cosine 2x over 2. Alright, and now for tangent squared x, of course, the easiest way to do tangent is take a look at tangent squared of x. This, of course, is just sine squared of x over cosine squared of x. My sine squared is 1 minus cosine 2x all over 2. And my cosine squared is 1 plus cosine 2x all over 2. So our 2's cancel here, and this resolves down to 1 minus cosine 2x over 1 plus cosine 2x. Exactly what we want. Alright, so these are our formulas for reducing powers. Now let's take a look at an example that might utilize these. Write sine to the fourth x in terms of first power cosine. So let's try to work this one out. So sine to the fourth x, we can write this as sine squared x times sine squared x. And now plugging in my reducing power formula for sine squared x, I know that this is 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2, or we could just write this as squared. Now I want to distribute this through. This isn't in powers, or this isn't in terms of first power cosine yet. I do have a first power cosine here, but this whole thing's squared, so I need to distribute it through and get rid of any squareds that occur because of this raising to that power. So my denominator is just 2 squared, which gives us 4, and 1 minus cosine 2x squared gives me 1 minus 2 cosine 2x plus cosine squared 2x. So now I need to get rid of this cosine squared. That's where we're at now. That's where we need to focus our energies. So I'm going to substitute in my lowering power formula for cosine. Now remember, cosine squared of x is 1 plus cosine of 2x over 2. So I'm going to leave this blank for a second. We need to figure this out. So what do I put here? Okay, let's go take a look at our formula. Cosine squared of x is equal to 1 plus cosine of 2x over 2. So my question is, what is cosine squared of 2x? Well, all that we have to do is we take this formula, and this is just giving us this relationship. So if I have cosine squared of x, then here I need cosine of 2x. So in other words, if I have cosine of 2x, then 2x here is playing my role of x in my original equation. So cosine squared of 2x is cosine of 2 times whatever is playing the role of x, which in this case is 2x. So coming back to our problem, cosine squared of 2x is going to give us 1 plus cosine of 4x over 2. Okay, we need to be very careful here. Now I need to get a common denominator up in the top here. Getting a common denominator, this is going to be 2 minus 4 cosine 2x plus 1 plus cosine 4x. My numerator is a fraction with denominator 2, and this is all over 4. So you can think of this as multiplying the numerator by 1/4 or dividing by 4. Any way you think about it, this 4 and this 2 are going to be joining together now in my denominator. So this is going to be all over 8. I have a 1 and a 2, so those add up to 3. So I have 3 minus 4 cosine 2x plus cosine 4x. Alright, and we're done. We wanted to write sine to the 4th x in terms of first power cosine. Now it doesn't say anything about the argument, so we don't have to worry about this 2x here or this 4x here. We're down to first power cosine. That's the only trig function we have present is cosine to the power 1. Alright, that's it for this video. In the next video, we're going to be introducing what we call the half angle formulas. We'll see you there.